Okay guys, welcome back from break. Today we're going to talk about the additive property of equality with decimals. So this is something we've covered, except we just didn't do it with decimals the last time. So we have a problem that says solve for y, and the problem I'm just going to recopy here at the top so we have a little bit more room. Y plus 7 and 68 hundredths equals 9 and 91 hundredths. So that's our problem, and what we need to do here is we need to isolate the variable, which means isolate that y. And so what we can do is we can draw our balance here because we need this equation to balance, and we need to get the y by itself. How we do that, if you remember, is we do the inverse operation to both sides. So the inverse of addition in this particular problem, since we're doing y plus 7 and 68 hundredths equals 9 and 91 hundredths, we are going to subtract. So we subtract out the same amount, and what I like to do is these cancel out, so I just kind of scribble through those, and then I have to do that to both sides. And when I do that, I get the y by itself, and that y equals, and if I subtract that out, I'm going to get 2 and 23 hundredths. So that's how we isolated that y by doing the inverse operation, or subtraction there, since it was an addition problem. So that's how we isolate the variable and solve for y on that. Okay? So let's practice one more. On this problem we have x plus 1 and 7/10 equals 6 and 57 hundredths. So on this one, same process. We need to isolate that variable x. So we're going to draw our balance, and we are going to do the inverse operation, where since this is an addition problem, we're going to do subtraction. Take 1 and 7/10 from one side, isolate that variable, and take 1 and 7/10 from the other side. Subtract that out, these cancel. So leave that x by itself, and x equals, if you do that math, it ends up being 4 and 87 hundredths. So again, pretty simple, really step-by-step process on how to isolate that variable, and that's the additive property of equality. And you would do that if it was a subtraction problem. You would just do addition to both sides, and vice versa. So that's how you do those. Now let's move on to the multiplication. Alright, so now we have this problem, 12 and 5/10 equals x over 5. And I'm actually going to rewrite this, because remember that if we have x over 5 here, that's division. The fractions are division. So I'm actually going to rewrite this, and I'd like for you to do that too, as x divided by 5 equals 12 and 5/10. So that's the same thing. I just reversed the order on those. So same process as before. We're going to draw our balance, and we're going to isolate the variable x by itself by using inverse operation. So the inverse operation of division is multiplication. So I am going to take x times 5, and that will isolate my variable, and I have to do that to both sides, so I need to multiply by 5, and if I do 12.5 times 5 and calculate that out, I will end up getting 62, maybe 62 and 5/10. So again, I basically used inverse operations. This was division, I just rewrote it, and used multiplication to cancel these out and get the x by itself, and then 12 and 5/10 times 5, and I end up getting 62 and 5/10 as my answer in solving for x. So that's the answer to this problem up here, and that's the multiplication property of equality using decimals. Okay guys, last problem. We have 7v equals 17 and 5/10, and we're going to do the same process. I'm not going to rewrite this one because I got enough room here. I'm going to draw my balance first, and then I have to think about, okay, what's 7v mean? Remember 7v, when we're looking at algebra, that means 7 times v. That's multiplication. So the inverse of multiplication is division. So what I need to do is divide 7 from both sides to isolate that variable. And the way I usually write this is I just write that as if that's a fraction, because 7 divided by 7, that's going to equal 1, and that would get your v, your variable by itself. And then if I take 17 and 5/10 and divide it by 7, that will give me my answer. If I do that, you should come out with 2 and 5/10. Okay, so let's do that as in a long division way. 17.5 and divided by 7. 7 goes into 17 2 times. 2 times 7 is 14. Subtract that out, and you get 3. Bring down your 5. 7 goes into 5. Or 7 goes into 35 5 times. And 5 times 7 is 35. Subtract that and you get 0. And if I could always check my work by taking 2 and 5/10, multiplying it by 7 to make sure I get 17.5. So that is how you do that one. Really the same process, using isolating the variable using inverse operations. So if you have more questions, feel free to message me and I can touch base with you. I also may do a Zoom meeting this week to kind of go over this and answer some questions too. So get your homework done, 4 problems, and we'll move on tomorrow.